So consider the equation negative 6 times x equals 4 minus 2y. If you graph the equation, what shape would it have, and how can you tell? Well, this would be a line, and the way that I know is a couple of things, right? Um, a line. One of the reasons I think I know that it would be alignable is experience, right? I'm bloody old and I've been looking at these for a long time. But beyond that, I'll notice that I don't have any quadratic terms in this variable. Like a quadratic would look something like, x squared. There's no squared variables in it. Everything's just to the first power. The other thing I don't have is I don't have a situation where I've got maybe like, for example, 2 raised to the x power, right? This right here produces what we call uh, exponential equation, or the geometric sequences, exponential equations, and these are quadratics, right? I don't have either one of these, so this is going to be a linear equation. It's a line. B, let's see, last time I did this last year, I messed up. Let me try and get this right. It says without changing the form of the equation. So they want me to tie a hand behind my back and look at it like this. So negative 6x equals 4 minus 2y. So I need to look at the equation like this and decide some points. It says find 3 points that must be on the graph of the equation. Then graph it on your paper. So I'm not going to change the form of it. I'm going to do this. Well, look, if x is 0, it would be nice, right? Because all of a sudden this left-hand side would become 0. So let's say that x is 0. Okay, then this equation becomes 0 equals 4 minus 2y. I could solve that for y by adding 2y to both sides. So I get that 2y is 4, and then if I divide both sides by 2, I get that y is the number 2. So 1 point, right, so far that I have is x is 0, y is 2. So let me put a dot there. X is 0, y is 2. So that point should be on the line. Oh, that's fun. Let's do that again. This time I'm gonna pick negative 2 for x. So if x is the number, oops, go back to black. If x is the number negative 2, I'm plugging negative 2 in the equation. When I plug that in, it becomes a positive 12 on the left-hand side. Again, I'm just looking at this equation each time, right? So that's negative 6 times negative 2 is 12, and that equals 4 minus 2y. If I take away 4 from both sides, it becomes 8 equals negative 2y. And then when I divide by negative 2, I get negative 4. So I get y is negative 4. So if x is negative 2, y should apparently be negative 4. So let me put that point down. Negative 2, negative 4. So I believe this should also be a point on the line. I don't know why I'm not really color coding it, but negative 2, negative 4. Okay, so a third point. Okay, I can do this. One last point I'll do is let's just say x is positive, I don't know. I'll say that x is positive 3. If x is positive 3, then again, that same equation up there would yield negative 18. 3 times 6 is 18. So negative 18 equals 4 minus 2y. Take away 4 from both sides. That gives me negative 14 equals negative 2y. Okay, and then if I divide both sides by 2, I should get that, well, 7 is what y is. Positive 7 is what y is. So 3, 7 should be another point. So let's go 3 and then up to 7. Well, the thing I'm liking is it clearly looks... Uh-oh. Did I make a mistake somewhere? Sure feels like I've made a mistake somewhere. I mean, these don't look like they're linear points. I put in 3... oh, I did make a mistake, didn't I? Oh, I'm so glad maybe you can see the mistake I made. The mistake that I made was I added 4 to both sides, right? and I was supposed to subtract 4 from both sides. So let me take away 4, take away 4. Because all of a sudden, here's what slammed the brakes onto me. I'm like, and look at those. Those are not a line, right? If I draw a line that goes through those points, it's like missing one of them. So it's like, whoa, hold on there. So I'm supposed to take away 4. Negative 18 minus 4 would be negative 22. Oh, and that equals negative 2y. Divide by negative 2, I get 11 is what y is. Totally different, right? This point should not be here. It should be at 11, which just barely fits at the very tippy top of this graph, right? That point would be the 11. Okay, so super. I played the game. I solved it. And what I'm doing each time is I'm solving for y each time. It's just a lot of work. It says, then graph the equation on paper. Okay, so I graph the equation on the paper and I can see it. Let me grab the line tool. Just go ahead and grab the, oh, geez. I didn't mean this to be this highlighter. I think I can change it after the fact. I'm going to make it a pen. I'll make it red and I'll make it, I don't know, that thick. There we go. So there's that line. Okay, kind of, right? It's a little bit off. It's not perfect. The next thing it says is solve the equation for y. Does your answer agree with your graph? If so, how do they agree? If not, check your work to find an error. So let's solve this equation for y. It's about time. That's what I did last year, as I did this first. But they wanted us to consider things. So if I'm solving this for y, I might do this. I might add 2y to both sides first and rewrite it as 2y minus 6 times x equals 4. And I'm going to add 6 x's to each side. So I get 2y equals 6 times x plus 4. And if I divide everything by 2, right, on both sides, or multiply both sides by 1/2, I get that y is 3x and then plus 2. So does this agree with my graph? Well, if I look at it, I should have a y-intercept of 2. And if I was a little bit more careful, right, yeah, right, that line's supposed to go through that point. And then I should have a slope of 3, which means I go up 3 over 1. And you can see up 1, 2, 3 over 1. This graph is just, I'm just not meeting the points here. You know what, it's worth it to me. Let's just draw that line one last time. So I'm going to try that again. Grab this tool right here and come up here. And you got to be careful. There's a place where you pause and then OneNote's like, okay, I'll go exactly where you want me to go. There we go. That's much better. And when you look at it now, yeah, it's clearly going through this point. It's going through this point, and then you can see up 3 over, close enough, right? Up 3 over 2. So certainly this does agree with my graph. And it says, if so, how do they agree? Well, I would say for C, they have the same slope pattern, right? Up 3 over 1. And also they have the same y-intercept. So yes, y equals, what was the equation? 3x plus 2. 3x plus 2 agrees with the line negative 6 times x equals 4 minus 2y. They're the same line, right? Just different forms of the equation.